Hi friends, today I will show how to make a compact voltage converter from 12 to 220 volts with stabilization of the output voltage. At once I will say that this converter produces a constant voltage at the output, so the devices containing a network iron transformer and AC motors can't be connected to it. This converter can provide an output power of up to 150 watts, although if desired, with some modifications you can get up to 400 watts. I will tell you about it later. I assembled this inverter for a small uninterruptible power supply. There will be a separate video about this design. About the shortcomings, there is no protection against short circuit, so the input and output must have fuses. Perhaps in the future I will finalize the circuit and add the electronic protection. Laptops, TVs and other devices can be safely connected, even the computer if you increase the power of the inverter. The advantage is in a stable output voltage because there is feedback and the pulse width modulation chip watches the voltage. Now about the design. It's a push-pull DC-DC converter based on CG3525 controller. Unlike the good well-known TL494, this chip has a powerful output and is capable to control powerful heavy gate transistors without an additional driver. Gates of FETs are the loads of the chip outputs and FETs control the pulse transformer. Voltage feedback is organized with a pair of linear diodes and an optocoupler. Linear diodes set the desired value of the output voltage. In my version, two linear diodes are connected in series. Preferable to use linear diodes with the same stabilization voltage. For example, two pieces of 110 volts for the total 220 volts. Optocoupler is any, in my case taken from the computer power supply. On the body of such optocouplers there is a dot key. It is also marked on PCB, so that even beginners will not confuse the connection. In this sample, field effect transistors are IRFZ44, although it is possible to use more powerful ones. FETs are installed on a common radiator, but they are isolated from it by mica or any other electrical insulating, heat-conducting one. At first I didn't use the original FETs and had to pay for it. When working on a 100 watt load, they exploded after a couple of seconds. Unfortunately, this moment was not captured on the video. And what you see now is already better samples. Up to 60 watts non-original keys worked perfectly. By the way, at the same time the chip burned too. Therefore, needs to pay close attention to the quality of the transistors and chips. Many people ask me for links to manufacturers who sell original keys. Now I don't even know what to advise. It happens that the same seller sends the original, you're happy. You order from him again and already a fake comes. Unfortunately, it is unpredictable. The operating frequency of the chip with this layout is 47 to 50 kHz, depending on the component's tolerance. The board has a remote control function. The circuit could start up by supplying a low current plus to the controller circuit or by adding a low power switch, so that no need to disconnect the power wires from the battery every time. It is a desired function in UPS. There is also a LED indicator and a reverse polarity protection function. This function is based on a conventional diode, which simply locks in case if you mix up the polarity of the power supply. Transformer winding data will depend solely on the type and size of the core, calculated by a specialized program. A link to the program will be in the description. In my case, the core is taken from a computer power supply. The actual power is no more than 150 watts. The primary winding is wound with a bundle of 4 wires of 0.6 mm each, 5 turns in each arm. Then the windings are phased in the following way to form the midpoint. It insulated with heat-resistant tape. A link to this also is in the description. The secondary winding is wound by a wire of 0.5 mm and contains 105 turns, and after every 30 turns it also put the insulation. At output, used a full-wave rectifier based on FR107 pulse diodes. Any impulse or high-speed diodes with a current of not less than 1 ampere and a reverse voltage of at least 400 volt are suitable. The inverter doesn't need much adjustment. Before assembling, it is necessary to check all the components for operation. Before soldering the transformer, it is worth to check the presence of impulses on the gates of FETs. If it is okay, connect the transformer. The ideal current of it is only 50 to 60 mA. It is very good even for such a small inverter, all thanks to feedback and control. The minimum supply voltage is 8 volt. Therefore, such an inverter can greatly discharge your battery. So I advise you to monitor the voltage on battery or supplement the circuit with a simple protection from low voltage. Such addition I will show in the next video when I will collect the UPS. To increase the output power, FETs need to be replaced by more powerful ones, say IRF3205. Add a second pair, and of course, replace the transformer with a more powerful one. Replace the output rectifier, the electrolytic capacitor, and the fuse, and the circuit will work like this. With this approach, the inverter can develop a power of 300 to 400 watts. I sincerely hope that the video was useful. All the necessary information, including the circuit boards and links to buy of exactly such inverters but without stabilization, is in the description. Now I have to say goodbye. Have a nice day. With you was Kasyan TV.